All right, let's talk a little bit about steel skeleton building construction. As welders, we are involved in two different aspects of steel construction and buildings. There's one aspect is actually assembling the building on the job site, the erection of the steel structure. The other aspect is fabricating the steel in the shop. See, one of the big differences between, say, carpenters and iron workers is that a truck will pull onto a job site full of lumber, 2x4s, 2x6s, plywood, all this stuff, and the truck will dump it off in stock lengths. You'll have, 10-foot 2x4s, 8-foot 2x4s, 4x8 sheets of plywood. And what the carpenters do is they cut it all to size and they nail it together and assemble it there on the job site. If you are building a steel frame building, as an iron worker, it doesn't happen like that. All your steel components come to the job site prefabricated, cut the shape, cut the size, all the connection points are assembled, welded together, bolt holes in it. Basically what the erection crew does is they sort out the load of steel, and per the blueprints they assemble it one piece at a time, kind of like Legos. So there's not a whole lot of fabrication that goes on a construction site because it all arrives at the job site pre-assembled. There are things that either were built wrong, designed wrong, or things that are designed to be assembled and welded in the field. But for the most part, a building is the parts are prefabricated in the shop to a particular configuration, shipped out to the job site, and then assembled in the field. So, as welders, one career that we can pursue is a career in construction. Another career that we can pursue is one in shop fabrication. I spent about 10 years in fabrication shops, fabricating mostly structural steel, actually a lot of miscellaneous steel like handrail and stairs and miscellaneous steel. And then for the last 17 years, I've been an iron worker. When school lets out, I sometimes take short-term jobs and during break to clear my head and so forth. But let's talk about steel frame construction, and here we go. Okay, buildings use a variety of steel shapes, which we talked about last week. We talked about wide flange beams. We talked about structural iron, angle irons. We talked about hollow structural sections like round tube, square tube, rectangular tube. We talked about flat bar. We talked about plate. We talked about channel. So, buildings use a variety of steel shapes. Now, the most common method of joining these is bolting, and then welding is a close second. As I said, a lot of your structural steel members are fabricated in a shop to have all the connection points ready, so all that has to happen is it has to be bolted together. Now, connections. Let's talk a little engineering now, because I'm a believer that the more you know, the better the welder and the better employee you are. Connections must transfer the live and dead loads to the ground. Now, a live load is a load that is that's not permanent. It moves. So when we say load, we're talking about the weight that is applied to the top of the beam here. When the roof goes on or the floor goes in, and there's a load applied to it. That load has to travel along the horizontal member and down the vertical member to the ground. The foundation has to be transferred to the native ground that the building is in. Now, a live load is people. On a bridge, a live load would be cars and trucks. if we're talking about a dead load is the weight of the building itself and the components of the building that are permanently part of the building. For instance, a roof is either going to have shingles on it, it's going to have hot tar on it, it's going to have rubber membrane or some kind of waterproof membrane on it. Those are all part of the dead load. The static load doesn't change. It's always there. The live load would be the wind, the rain, the snow, people walking on the roof. That is all the live load. So when the engineers design these buildings, they have to design them not only to carry the weight of the building itself, the dead load, it also has to be able to withstand the live load and be able to successfully transmit the weight of this from each floor down the vertical members into the foundation or the ground. Okay? Now, steel frame construction eliminates load-bearing walls. Most houses, the roof is supported by the walls. And let's talk about this. Okay, a few years ago I worked on a building in Pioneer Square. Well, I've worked on a couple of buildings in Pioneer Square. But I spent a pretty good amount of time on one building in Pioneer Square called Compass Center. You can Google it if you want. And it is a typical 1800s era building. Okay? It is designed, and this is just a shot from Pioneer Square, it is designed so that you have a brick wall that gets bigger towards the base and smaller towards the top. And so you've got 4 brick walls. I'm just going to draw 2 because the building's in cross section. Oh, that's terrible. And what I noticed on this building that the Compass Center, and all these old brick buildings in Pioneer Square is the base of the wall, when we were working in the basement connecting a couple of buildings together, the base of the wall is like 5 feet thick. When you go in these doorways here, in these buildings in Pioneer Square, you notice that the walls are very, very thick. Now, at the top of the building, which was 5 stories tall, 5 or 6 stories tall, the Compass Center one was, and then they're all pretty much the same down there. It's only 2 bricks wide, whereas the bottom was like 5 feet wide. It's like a pyramid. Okay, now each floor has got like a big 2 by 14, 2 by 12, whatever, huge piece of lumber in here, and it's bolted through the building. And if you look on a lot of these buildings, at each floor you'll see this little cast iron circle called a rosette with a nut in the middle. That holds that bolt in, which holds the floor, or actually this board. And then you've got the, great, this is supposed to be straight, boys and girls. It's not. You've got the lumber that goes across for the floor, and then the floor is built on top of that. So at every floor, you've got this configuration where you've got these boards that go across, and at this Compass Center, we did a lot of work on this building. They were cutting these boards out. These things were like 40 and 60 feet long, 2 or 3 inches thick, 14 inches deep, solid wood, not a knot in them, straight grain, old growth timber. They were cutting them up and throwing them out. It made me sick to see that. Nothing I could do. I didn't have any means to transport this stuff. I didn't have anywhere to store it. I didn't have any woodworking equipment because I'm an iron worker. I'm not a carpenter. But I just hated to see that stuff get thrown out because it's stuff that you're never going to see again for hundreds of years. Old growth wood. And so at the top, it was like 2 bricks wide. So you got the rosette on the outside with a nut in it. And so all of the load that is transferred to that is applied to each floor is transferred horizontally to the walls and then down to the base. Now, because of this design, you're limited to about 5 stories in height. Now, after the Great Chicago Fire of like 1880 or something like that, they came up with a new design called steel skeleton building or steel frame construction. So now you've got all of your members, your vertical members, are steel, which means you don't have to have huge bases 5 feet thick to support the building. The building has a series of columns that transfer the load vertically. So this right here, along with the invention of the elevator, allowed buildings to be built much higher than 5 stories. We're building buildings over 100 stories now. Okay, so steel frame construction allowed us to build much higher than we previously could. Okay, so let's talk about some terminology, and then we'll knock it off for this particular lecture. Okay, structural steel building terminology. A column or column, however you want to pronounce it, is the vertical member that transfers the load to the ground vertically. It's in compression. Okay, so that is a column. Okay, now a girder is a main horizontal support, and it runs between columns. Okay, so it's a huge piece of steel, relatively speaking, to the other things. As you see, it's bigger than the column itself. Now the column may have thicker flanges, but this is a very deep section of steel. Now the beams are intermediate horizontal supports, and they connect to the girders. Okay, so a beam is horizontal, but the girder has a lot of other horizontal members that tie into it. See, trusses replace girders for long spans in roofs and floors. So there are no trusses on this building. However, there are bar joists on this building. This is a joist, and it's a light member. There's not a lot of load that's going to go on this, but all the load from this is going to get transferred to the girder. All the load from this one is going to get transferred to the girder. So all of these joists and all of the intermediate beams that run this way tie into the girders, so the girders are actually carrying all of the weight from this is going into these girders right here. So they are usually, the girders and the columns are the largest structural members on a building because they carry the most weight and transfer it to the ground. Okay, so column, vertical. Girder, horizontal, transfers all of the weight from the other horizontal members to the columns, ties into the column right there. Beams are intermediate sized horizontal supports. They go from girder to girder, or sometimes in this case from column to column. Trusses are very long, they go over long spans, and I don't have any photographs of trusses on this slide. And joists are the lightweight members that go from girder to girder. And each of them takes a little bit of the load and transfers the load to the girder, the girder. All right, so we will come back and we will talk about measuring terminology. We've talked about steel frame construction, how it differs in wall-supported buildings. We talked about the individual components of a structural steel building. And when we come back, we will talk about measuring terminology. Thank you.